And can you hear me okay? You want a longer break, Joel? Okay. I sent you guys a document. So that's a good reference sheet. So we're going to be talking about that. Did everybody get that document? It was called, I think, A+ TCP IP Notes. So if you could open that up, that'll be a good reference. Okay, so what we have here on the board, this is a typical IP address. It's called an Ipv4 address. That's just version 4. We just got back. Nanette. Sorry about that. I didn't realize it was break time. Ah, you're on a phone or photo viewer? It should be a document. Maybe you don't have a document reader on there. I'm going to be cutting and pasting them onto the whiteboard in sections anyway, so I wouldn't worry about it. It's just a document, Word or OpenOffice or WordPad. I was drawing a blank there. WordPad or Notepad should be able to open it. Now, Bruce, are you on a computer at New Horizons or at home? Maybe they just don't have Word installed. That's what I'm thinking. Let me see if I could save that as a text version. Give me 1 second. And then you should be able to open that at Notepad. You're not missing anything yet, Nanette. We just got back from break. So I did send a file. I don't know if you got the attachment. Does WordPad open a DOC file? Okay, I think what's going to happen is I have some tables in here. If I convert this to a text, it doesn't look good at all. All right, just give me 1 second. Let me share out my desktop. Okay, let me just give you a quick peek at the file. And I'm going to cut and paste these onto the whiteboard in sections. Okay, I already got the bottom piece here, that binary thing. So Bruce, you should be able to, make sure you save it. You should be able to open it at home, no problem. Okay. So this is a TCP IP version 4 address. It happens to have 4 sections. Right, 1, 2, 3, 4. And like I said, that's called dotted decimal notation. Now when TCP IP first came out, it was considered classful addressing. There were classes. Does anybody know what the classes are called? Throw that out in chat. Great, yeah, typically they were A, B, C, D, and E. So for A+, you only need to know about A, B, and C. Now, like I said, there's 4 components for an IP address. 1, 2, 3, 4. So you could almost think about it as like A, representing the first component, dot B for the second component, dot C for the third, dot D for the fourth. And what happens is this subnet mask helps you determine what the network is. So for a class A, the network is represented by the first component only. So if I draw a little box about that, so that's what the 255 means. All right, that's the network portion. So the subnet mask for class A is 255.0.0.0. Again, these are called octets on the top. Each one of these, I can't point to it. This is an octet, that's an octet, that's an octet, that's an octet. We're going to talk about that in a minute. But if I use the terms, I want you to understand what I'm talking about. Yeah, a little bit. You got a question, Fred? I see your... What's your question? Well, he's typing. I'm just going to keep going on. For Class B, as you can see, the Class B 255.255 represents the network. It uses 2 octets for the network and then 2 octets to represent the host itself. So whatever I have in the blue boxes, that's kind of like your city and state that we talked about before, right? That represents the network. And then the zeros are the individual house numbers. So just stand by for 1 second, guys. Sorry about that, folks. I just had to step away for a second. Okay, Fred. Well, we're going to talk about some of that today, and I could certainly help you with any references. Yeah, let's go over this and let's see how it goes. When we're done, if you need more references, let me know, okay? And at the end of the class, I don't want to hold everybody up. I have to jog my mind a little bit. Okay. So again, it's very important that you just understand the what the network portion is versus the host portion, okay? And hopefully it's not too complicated. I know it's a lot if you're learning it for the first time. For Class C uses 3 octets to represent the network portion and then only 1 to represent hosts. So if you think of these as containers and how many marbles you could put in the container, well, Each one of these containers only holds 256 marbles. So this could only address 256 addresses for a Class C, right? That's how many houses you could have in that city and state combination. Whereas Class B, you could have just as many houses because you have 2 octets as you have networks. With Class A, you only have, I guess I should use 255. The numbers go from 1 to 255, but it's 256 combinations. So sometimes it gets a little confusing. But with A, you could have 255 networks, but a lot more houses. So it depends on what your company was looking for. It turns out that if you have too many houses in one small city and state, you got too much traffic. There's cars all over the place. They're always waiting at stoplights. They can't get to the grocery store without waiting online. It's just too congested. So the same thing with network. Having too many computers on the same network causes way too much traffic. So Class C actually works pretty well. So I want to break down each one of these apart. I want to explain what I call these octets. There's 4 octets. I want to explain what that is. What does oct mean? Where does that come from? OCT. Good, that means the number 8, like an octopus has 8 legs. So down here, I drew 8 dashes. This represents 8 bits. What's another word for 8 bits? Great, 1 byte. So I'm going to write that down here. 1 byte equals 8 bits. So what we have over here, these are 8 bits. Now these are called placeholders. And just to give you an example, let me move this over a little bit, give myself some room. Let's get away from binary for a second. Let me put that number out there for a second. 1,629. Do we know how much that is? Does that mean something to us? Lots of money. It's nice. I wish I had that right now. So that kind of means something to us. How about this? Does that mean much? I mean, just at a quick glance, no. It's very confusing. We would need to know how to break that down, right? This means a little bit more to us. Some of us are probably familiar with seeing certain IP addresses. So I just want to explain what binary is, okay? We're going to relate it to the decimal system first. So we're going back to the numbers that we know. And let's talk about money, because I like money. So if I was to write the dashes here, well, that's a thick line. All right, I'm going to go with it. I want to represent 4 placeholders because that's what my numbers are. Right? I'm just going to write them in here again. I'm just writing that number down. So 1,629. So remember from elementary school, we learned what the 9 was, what position that was, right? This is the ones position, right? That's like having 9 single dollar bills. So I'm going to write that in. That's called like the one placeholder. What position is this in decimal or money talk, the 2? That's the tens, very good. That's like having 2 $10 bills. How about the 6? What position is that? Ah, you guys are following my pattern here. That's like having 6 $100 bills. And you guys already got that. 1,000 is the last placeholder. So, which would you rather? The 9's a bigger number, right? Would you rather 9 ones or 1 1,000? Ah, both, yeah. So, another way to look at this, if we were to add this up, it's 1 times 1,000 is 1,000. This is if we were to break it down, right? And then 6 times 100 is 600. 2 times 10 is 20. You follow me, folks? 9 times 1 is 9. If I was to add all of that up, I'm going to get the results I was thinking of. So it's going to be 1,629, right? So let's just do a little conversion in binary. Everyone's with me so far, right? Give me green check marks, red X's if not. Excellent. I'm going to just put some random numbers in here. I'm just going to do 1. Oops. Okay? So I'll give you guys just a quick minute. I want you guys to try to figure that out. Or think about what you're going to do as I'm starting to write it in myself. So now with binary, binary is base 2. I'm sorry, let me step back for a second. I apologize, I forgot something. So with the decimal system, it's called base 10. We have 10 choices. I'm going to write over here on the right, base 10, you have values 0 through 9. Binary is base 2. And you have values 0 through 1. So when you have your base 10, if we look at our placeholders, we had 1. We have a maximum of 10 combinations, 0 through 9, that could be in this position. And then what happens when we get to 9 and we add 1? What's 9 plus 1 in decimal? It's just regular math. It's 10. You fall over into the next field. So 9 plus 1 is 10. So it would be 1, 0. So that's how this becomes the 10 placeholder. It's base 10. So 1 times 10 is 10. Times 10 is 100. Times 10 is 1,000. And it keeps going on and on and on. Times 10, times 10, times 10. That's how the number system goes until you keep going 10 times 10 times 10 and you get to a Googleplex. All right, so with binary, we start with 1. Okay, this part stays the same. But with binary, it's base 2. So now we're going to multiply by 2. So these placeholders, or these values, double. 1 times 2 is 2. Times 2 is 4. Times 2 is 8. Times 2 is 16. 32, 64, 128. They double. So if you could remember that, if you can remember 8 bits in a byte, and it starts with 1 on the right, you just got to multiply by 2 because it's base 2, and you should be able to fill in these placeholders at any given time. Does that make sense? Everybody with me? So similar to the way we did the conversion from that number, and we converted 1 times 1,000, 6 times 100, 2 times 10, 9 times 1. And then we added it all up over here. We're going to do the same thing for this number. We're going to start over here and then work our way to the right. So let me just put my little hand here. I guess I lose it anyway. So there's a 1 in the 128 position. If I do 1 times 128, what do we get? Yeah, 128. 0 times 64. It's 0, so I'm not even going to add it. I'm not even going to put it on here. 0 times 32. 0 again, right? How about 1 times 16? Good, that's 16, so that I have to add. 1 times 8? 8. I'm going to add that. 0 times 4? 0. I'm not going to put that in. 1 times 2 is 2. And then 0 times 1 is 0, so I'm not going to add that. Whoop. So now we would have to add all that up and figure out what that number is. $154? Anybody else add that? That's what I get. Oh, thank you. Thanks, TA. 154. So yay! You guys just converted your first binary number to decimal. How hard was that? Oops. Let me just move that, I guess, for a second. I want to clear out some of this board so we could do another one. Does anybody need this decimal stuff on the right here anymore? I'm going to get rid of this. Okay. I'll get that. That'll give me a little bit more room. So I'm just going to put another random number out here. And I'm going to want you guys to convert this so you could actually start converting it now. Now, what's a utility that you can use on your computer to add this stuff up? Good, Calc. You guys should all have access to Calc. piece. You guys are quick. Let me bring up my calc. Everyone should still try it. If you just click on Start and in the search type in Calc. Now, I mean, there's a little bit of a shortcut. We went through the whole process before. The bottom line is we know anything times 0 is 0. So we could almost ignore all the zeros. And anything times 1 is going to be the value itself. So the shortcut is you're just going to add up all the placeholders that have a 1 in it. Right, so you're going to convert, add up 64, 32, 8, 4, and 1. So very good, you guys got that right, 109. Matt, I hope you're kidding, you just reversed your numbers. All right, so does everybody got this? Give me green check marks if you get it. This is the foundation for a lot of things. So will this be on the test per se? Probably not. Will it help us to talk about the other lessons? Absolutely. Okay. What else? Let's put one more out there. Just another random one. I got to move this out of the way first. Okay. Good, 230. You just add them up. All right, you guys are really advanced. I'm going to really throw you for a loop. What if we want to convert this number right here to binary? How would we even go about that? What if I want to convert 192 to binary, to do it in reverse? If anybody thinks they have an answer, you could figure it out, and then you could put the binary value in chat. I'm going to keep going ahead to explain it because I want to make sure we got it. We got to get through this chapter today. Well, excellent. Right, so not necessarily 10s, 100s, and 1s, but 128, 64s, 32s, et cetera, So what you do is you start with the highest number first. It's kind of like that saying about time management with the jar. If you have rocks are your big projects and sand are the little tasks that you need to do on a daily basis. If you fill up that jar with all the sand and you're doing all these little tasks that you need to do on a daily basis, you're never going to fit those big rocks in. So in terms of time management, if you have these big projects that are going to set you going forward, you got to get some of those big rocks in, so you got to manage your time appropriately. Get the big rocks in the jar, and then you fill in the spaces with the sand. So if we were to start with the right and start figuring out, okay, I'm going to add 1 and then 2 and then 4, and then what happens if I get to the end and I'm somewhere between 64 and 128? I have no place to go. You want to start with the higher number first. So you look at 192 and say, is it higher or lower than 128? Well, it's higher, so that means I have to put a 1 here. So I know that 128 is on. So when I come over here to convert this number, I'm going to subtract 128 now from 92. And then I got to figure out my remainder. So what does that give me? Anybody got their calc still open? Good, that gives me 64 left. Well, now I compare 64 here with my next placeholder, which is 64. Well, those are equal, so I could put this on. So I got to put a 1 here. And now I come back over here, I'm going to subtract another 64. I'll do that math. That gives me 0 left. So now I know the rest are all zeros. That's how you convert decimal to binary. So what about the 168? How would you convert that to binary? And I'm going to clear our work area here. We got to look at 168. Is it higher or lower than 128? It's higher, so I could go ahead and put a 1 here, and now I'm going to subtract 128 from that. So 168 minus 128 is going to give me what, 40? You guys coming up with the same answer there? Now I compare 40 with 64. Ah, if I put a 1 here, that's going to be way too much. 64 is higher. So 64 has to be a 0. So now I'm comparing 40 with 32. I'm okay. If I put a 1 here, 32 is less than 40, so I'm good. So I'll put a 1 here. I gotta do my subtraction. That gives me 8 left over. Now I gotta compare 8 with 16. If I put a 1 here, I'm going to be too high, so that has to be a 0. Now I compare 8 with 8. They're equal, so that'll be a 1. If I subtract my 8, that's going to give me a result of 0, right? So that means the rest of my values are all 0. So excellent, you guys got that right. Everybody following along with this? Everybody good? Any questions? Okay. Whoops, I'm going to get rid of this. Just clear that out. All right, so one other thing we need to talk about is hex. What is hex? So hex is base 16. Now, your values are technically 0 through 15, right? But that's not really what they do. It's really 0 through F. And we'll explain that in a second. So I'm going to kind of put an X there because it's really not that. I split the byte in half. Hex is based on 4 bits. Anybody know what 4 bits is called? How about, it's called a nibble. You can see it spelled a couple of different ways. Well, heck, what else would half of a byte be, right? So let me just put, we're going to look at these four, whoops, I'm saying the word four, and that's not what I meant. I'm going to put ones in these four positions because that's how many bits we're talking about. 1, 1, 1, 1. What is this equal? Can someone add that up for me, please? Good. That equals 15. So that's why, so 0 through 15 is 16 different characters. So that's why hex is base 16. I'm just looking for room to write this. Okay, so that's actually all I need, 0 through 15. So this is decimal here. Okay, that's decimal there, and I'm going to write the corresponding hex. Okay, so a 0 in decimal is a 0 in hex. The whole purpose of hex is to represent the value in a single digit. So we're good up until 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So far we're good. You know, again, I'm going a little bit more deeper, but it's laying the foundation for everything. So if you guys have any questions, I'm only an email away. Please feel free to email me, even after the class is totally fine. So when we get to 10, we don't want to use a 1, 0 because that's 2 positions. So we start to use the alphabet. So they use A, B, C, D, E, and F. It's really that simple. It's not too hard. And sometimes I use my finger. I don't remember what a D is in hex, but I know an A is 10. So I would kind of count out, okay, A, B, C, D. I know that's 4, and I would do 10, 11, 12, 13. I do it on my fingers. So that's what hex is. So what I'd like to do is I want to write all these things out. I'm just going to create another slide. And we can always go back to that last one if you guys want to write anything down. I need some more work area, and I don't want to keep erasing that stuff. So let me real quickly just write that down. Wish I could get these things to line up. Jeez. Whoops. Now I'm really going to be messed up. I'm never going to line it up. Oh, I messed up both of those. Sorry. Thank you. C, D. see if I can move that down a little bit. Okay, that's a little bit better. So again, we got our 4 bits. Let me go up here for a second. All right, we're only going to use the first half. Let's draw a line. We're not going to use the left half. We're only going to use the right because that's what hex is all about. Those are the placeholders for hex. It's only 1, 2, 4, and 8. So now what I want to do is I want to convert hex to binary. Let me just move this over a little bit more and give myself some room. So going through this, we're only talking about 4 bits. Maybe it'll be helpful if I just delete this. Okay? Can somebody tell me what's the binary value for 0? I want it in 4 bits. While someone's typing in 0, I want 1. Somebody put the binary value in for 1. So 0, if I want to represent a hex 0 in binary, it's going to be 0, 0, 0, 0. That's what I was looking for. If I want to convert a 1 to binary, it would be 0, 0, 0, 1. Does that make sense? These are lower numbers, so hey, I'm pretty smart. I could do some of these in my head. Maybe only up to 4 though. So is everyone following me? If you have any problems, just give me a red X. So what would a 2 be? Yeah. You could almost double check. You could figure it out and then go backwards. So a 2 is 0, 0, 1, 0. And again, that would be like do a double check. 0, 0, 1, 0. Yeah, that's a 2. Okay, what's a 3? This is where we start to get a little tricky. A 3 in hex, or binary, I apologize. Good, 0, 0, 1, 1. How about a 4? That's kind of easy, right? 0, 1, 0, 0. A 5. Good, that's a 4 and a 1. 6. Good, that's a 4 and a 2, so 0, 1, 1, 0. 7. Good, so that's a 4, a 2, and a 1. So 4 plus 2 is 6, plus 1 is 7. So 0, 1, 1, 1. 8. Well, that one's real easy. Whoops. 9. Good, that's an 8 and a 1, 1, 0, 0, 1. An A, which I like to convert to decimal first, because, again, I forget what an A means. So A is 10. Well, 8 plus 2 is 10, so that would be 1, 0, 1, 0, right? How about 11? Good. 8 plus 2 is 10 plus 1 is 11. So 8, 2, and 1 are on. 1, 0, 1, 1. And then C is a 12. What's a 12? Good, that's a 8 and a 4. So 1, 1, 0, 0. 13. So 13, that's 8 plus 2 is 10 plus, nope, that's not enough. 8 plus 4 is 12 plus 1 is 13. So 1, 1, 0, 1. And then 14. Is going to be an 8 and a 4 is 12 plus 2 is 14. So 1, 1, 1, 0. No problem. And then what would 15 be? Yeah, 15's all ones. So 15's the highest. Woohoo! Okay, I gotcha. So that's binary and that's hex. So, I wanted you to understand where these hex values come from. Where do you see hex letters in A+? Anybody know? Good, a MAC address. A MAC address is full of numbers and letters. So those letters come from hex. So if you know your hex values, you know that the highest number you could have is 15. You could figure out A, B, C, D, E, F. F is the highest hex value you could have. So on an A+ test, if they ask you what's a valid MAC address, you got to make sure if they give you a letter other than A through F, you could cross those off right away. You know it's not a valid MAC address. Okay, so there's your conversion. Let's go back to this slide. In terms of that sheet, you know what I'll do? I'm going to cut and paste each section of that sheet for those of you that couldn't get it. Okay, so here's one section. This is a good reference. So an IPv4 address is 32 bits. There were 4 octets. Each octet has 8 bits. So 8 times 4 is 32. So a typical IP address, this is what class is this? Can someone tell me what class it is based on the subnet mask? Good, it's a C. Because a C has 3 sets of 255s. So what that means is the network stops really at the 3rd octet, and then the 4th one is for the host. So this is the IP address of a node or a host. This could be a computer or a printer or a server, something like that. And when you look at your TCP IP configuration, you need a subnet mask, because without it, that's just like saying I live on 43 Main Street. The subnet mask tells me the city and state. It tells me that 192.168.1, really .0, I put it down here. This is the definition of the city and state also. This kind of goes hand in hand with the subnet mask. So for the Network Plus folks, you're going to see this later on. So that's all you need. You need an IP address and a subnet mask to be able to communicate on an TCP IP network. But if you want to get out to the internet, or you want to get out to another network, I said you need a router, right? A router connects two networks together. So the default gateway is the IP address of your router. Now this just happens to be the common IP address for many home routers. It doesn't have to be that, but it is somewhat of a standard. So I put it here. So that's the IP address of your router. That's also known as the default gateway. When you do an ipconfig/all, you'll see all this information. So again, for this computer, the network that it's on is called this, 192.168.1.0. Now there's something called broadcast. Broadcast is a TCP IP packet that goes out to all computers on the network. And that's when all those host bits are ones. So we're going to just suffice it to say 192.168.1.255 is 0. Let me go back a couple of slides here. If I was to do a 1 here, a 1 here, and I take away this line, if I was to add 128 plus 64 plus, you know what? I'm going to be adding all these up. Can someone add these on their calculator for me, please? What does that all equal up to? So that's when they're all on. That's when a whole byte has all ones. You sure about that? Anybody come up with a 2 number? Okay, so I got 2 different, All right, do I got a tiebreaker? Anybody else? 255. That is correct. From 0 to 255, that gives you 256 combinations. But if you add them up, 255 is the highest number you could have, okay? So there's no coincidence. It kind of means something. That's why you kind of see these 255s here. And that's what this 255 here means. You just need to know 255 is reserved for broadcast, okay? Now, we talked about running out of Ipv4 addresses, and I said they made some changes so that we didn't really run out of them that quick. One of the changes, rather than sticking to these strict classes where you had exactly 1 octet for Class A, 2 for Class B, and 3 for Class C, they're going to let you have different combinations. So they came up with a new standard called CIDR. Can someone tell me what CIDR stands for? Classless Internet Domain Routing. So they're getting away from what's called classes. Good. So we now know 1 octet is 8 bytes. So instead of writing 255.000 with CIDR notation, I could just say 8 bytes represent my network. Well, with Class B, we have 2 bytes that represent the network. So what's 8 plus 8? Well, that's 16. So in CIDR notation, you'll just see /16. And C uses 3 octets. So 8 plus 8 plus 8 is 24, so it's also known as /24. So it could be reasonable to see a question like this on the test, and it's a definite for Network Plus. And I don't know why I've been getting my slashes backwards. I don't remember which way the slash goes. It doesn't matter though. So you should know that 24 means 24 bits are used for the network. That's what that means. That's all that means, okay? So I just wanted to throw that out to you now. So that's the first portion of the chart I gave you. Let's see what I'm trying to see what I'm going to be able to fit on the screen here. All right, this is just another similar thing. We already talked about the different subnet masks. One of the things you need to know are these octets. The ranges of what an IP address starts with. So it is a standard. Going back to class full address in class A, B, and C, you actually don't need to know D and E. We said 192 is, I wrote it here as 255.255.255.0. So what class is that? Good, that's class C. And if I happen to look at the 192 here, I look in class C, look at that. There's a standard on my chart that says a class C, any IP address with the first octet starting between 192 and 223 is class C. Now, you do not need to know D and E for the test, okay? So what some people do is they'll memorize B as being 128 to 191, and they know anything less than 128 is Class A. Anything more than 191 is Class C. That's one way to memorize it. So you do need to know that for A+. I'm going to show you another little trick, and I think this might, lose some of you. I can certainly help you outside of class if you need more help on it, okay? But I just want to show you this one last trick. I'm going to put D and E back. Whoop. Wrong tool. I'm going to build this chart. I'm just trying to save some time here, so let me grab. Okay. Can I put it? I'm going to put it over here. Okay, I don't need that anymore. I just need that. I need that little chart. So there's a range, okay? I'm going to work with Class A first. Well, I know Class A is the lowest possible value. So I'm going to cheat a little bit. Class A is pretty much when everything is 0, right? You can't have a 0 IP address. Certainly not something that starts with 0. You could have a 0 somewhere else in one of the other octets. You can't have it in the last octet, and you can't have it in the first octet. But in the second or third, you could have a 0. So what's the lowest value you could have? if I have 0, 0, 0, 0, 0, 0, 0, 1, my value is going to be a 1. So the very lowest value you could have is 1. So that's where a Class A is going to start. Now I'm going to do a little trick. If I put a 1 here, and assuming the rest are all zeros, what's my value? Good, 128. Well, that happens to be where Class B starts. Now, if I put another 1 here, and the rest are all zeros, what's my value? It's 128 plus 64. Good, thank you, it's 192. So that's where C starts. I'm going to put another 1 here, and I'm going to pretend that these are all zeros. So what's 128 plus 64 plus 32? Good, 224. That's where D starts. I apologize. And then, well, guess what I'm going to do? I'm going to put another 1 here. And now we got to add all that up. I'm going to assume these are all zeros. I got to add 128, 64, 32, and 16. That gives me 240. All right. So now that we have our starting IP addresses for each range, I know I can't have overlapping IP addresses. So A has to end before Class B starts. So if B starts at 128, A has to end at least before that. So 128 minus 1 is 127. Now, 127 happens to be reserved for loopback. And that is on the sheet I gave you. I just want to try to where can I put that? And let me just throw it up here, okay? 127 is reserved for loopback. So we're going to end A at 126. So I know Class C starts at 192. So Class B has to end 1 before that. So where does B end? $191. Class D starts at 224, so C has to end 1 before that. So that's going to be 223. E starts at 240, so D has to end 1 before that. Good, 239. And 255 is reserved for broadcast. We have that up here. That's when the computers are talking to everybody on that network. So we're reserving that for broadcast, so E is going to end at 254. So if you look at this, we just kind of reproduced this chart. And honestly, I wasn't looking at this when I came up with these numbers. 0 is reserved for the network ID itself. All right? So again, you don't need to know D and E for A+. But for those of you that are going on to Network Plus, you need to know it. And the process is the same, so I just wanted to show you that whole trick, okay? So hopefully that helps. But again, all you need to know, and you do need to know it, you need to know that. Questions? Any questions? I thought I saw somebody typing there. And one more thing. My PC is slowing down. Okay. Last thing from that sheet that I want to go over. Oops, just one more blank slide. Okay. Because there's so much malicious activity out there, you want to try to protect your network as much as possible. And there's a lot of people out on the internet that's trying to send viruses